your last problem setup for tonight is two buckets hanging by a massless cord from one another, from another 3.2 kilogram paint bucket. And it's also hanging by a massless cord as shown in figure 4.4. So we have two situations to solve for. In version A, if the buckets are at rest, we want to find, so at rest, what is Ft for this cord in between them. And for B, when the two buckets are pulled upward with an acceleration of 1.6 meters per second. So when acceleration equals positive 1.6 meters per second squared, right, that means that it's accelerating in the upward direction. We still want to know what the force of tension is for this cord right here that's separating them. And so that means that you're going to have to solve for both buckets. Alright, so here's a few hints for helping you solve this problem. If you look, you don't have just one system, you have two systems. So I would call them bucket A and I would call them bucket B. That means that you should have two free body diagrams, one for bucket A and one for bucket B, which means that you need to consider for each of these what all forces acting on each bucket are. Calling this one bucket A and calling this one bucket B, you would have that for bucket A, the net forces in the x direction would equal the mass of bucket A times the acceleration of bucket A in the x direction, and the sum of all forces on bucket A in the y direction would be the mass of bucket A times the acceleration of bucket A in the y direction. And then likewise you'd repeat that process for bucket B, where the sum of all forces in the x direction for bucket B would be m b a b x, and the sum of all forces in the y direction for bucket would be m b a b y. So before I even draw the free body diagram for this problem, there's a few things I need to consider. Well, the first thing is that these buckets are going to either be at rest or they're going to be moving upward. And they're attached on the top and the bottom, getting suspended in the air by two different strings. So the first thing that I'm going to decide is I'm going to decide there is no horizontal motion for problem question A or question B in the x direction, which means I am not going to have to resolve for the x direction. Which means that I'm only going to be interested in the vertical motion for bucket A and B. But I have the mass of bucket A and the mass of bucket B and the acceleration of bucket A and the acceleration of bucket B, and I'd really like to simplify that. So one of the things I'm going to remember is that they said that bucket A was 3.2 kilograms and that bucket B is 3.2 kilograms. And that means that the mass of bucket A is going to be equal to the mass of bucket B. So when I write these into the equation, I'm going to write both of them as mass m, which is awful convenient. And another thing that I'm going to remember is that as long as this string in between them stays taut, which means it doesn't stretch and it doesn't bend and it doesn't fold, that means that these buckets have to be moving together. So that means that the acceleration of bucket A is going to be equal to the acceleration of bucket B, which we can just call acceleration. Right, so that means that the force of bucket A is going to be equal to the mass times the acceleration, and the force of bucket B is going to be equal to the mass times the acceleration. I have not solved this problem for you at all, and in fact there's something else that you're going to have to remember and apply, having to do with Newton's first and second law to resolve for the difference between situation A and B. In addition to drawing a free body diagram for bucket A versus bucket B, well, bucket A, what's acting on it? Well, there's the force of tension there. There's the weight of the bucket, and there's also the force of tension downward from bucket to bucket, which I'll call force of tension 2. For bucket B, there's the force of tension 2, and then there's the weight of the bucket. So now I have 2 free body diagrams, 2 conceptual setups where I should be able to figure out the net force on bucket A and the net force on bucket B, and from these you should be able to calculate tension at rest, and B, tension and acceleration of positive 1.60 meters per second. So that sets you up really well to solve the third and final problem for this assignment. Make sure that all of your problems are submitted online and that you bring them to class in case you have questions.